it's genuinely hard not to be impressed by what AI, especially large language models, can do now. Writing, coding, chatting. It's pretty amazing stuff.
Oh, absolutely. The fluency is just, it's remarkable. It feels like a huge leap forward.
It really does. But there's this growing question, isn't there? How do we get these AIs to go beyond just sounding good to actually being, well, reliable and precise, especially in areas where deep knowledge really matters?
Exactly. That's the crux of it. Because sounding convincing is one thing, but being factually accurate and aligned with, say, scientific principles or complex business rules, that's another level entirely.
And that's where errors can really cause problems. Like education, research, critical systems, you need more than just plausible text. Which brings us right to our topic today. We're doing a deep dive into a lecture note called Ontology Model-centered Generation, OMG, Structuring Intelligence in the CAFA Framework.
Ah, yes, by Jaehwa Choi from George Washington University.
Well, yeah.
He actually invented the CAFA platform.
Right, the CAFA platform pronounced kind of like kappa. In this note, it seems to draw from training materials and an upcoming book chapter.
And it really argues that relying just on language models, what it calls OLOG, well, it has real limits for these high-stakes tasks.
So our mission, basically, is to unpack this OMG idea, using structured knowledge, these ontology models, as the core, the guide for AI generation.
Moving beyond just text generation toward actually structuring the AI's intelligence.
Yeah, it's like looking for a shortcut, a way to understand how we can build AI that's smarter, more trustworthy.
Okay, so to get why OMG is important, we probably need to talk about the current default, right?
Yeah.
This language model, only generation, or log.
Right, and log is great for lots of things, quick summaries, brainstorming ideas, even creative writing. It's got that breadth.
Totally.
Yeah.
But the note points out, and it makes sense, that when you need real precision, or you need to explain why the AI said something, or make sure it aligns perfectly with domain knowledge, log starts to struggle.
Yeah, the note lists a few key problems, like the content it generates. It might sound okay, but it often lacks that deep semantic structure. It doesn't quite map to how experts actually organize knowledge in their field.
And the knowledge it does use is sort of hidden away inside the model. It's implicit. You can't easily point to it or change it if it's wrong. That whole black box issue.
Right, the black box. Super frustrating when you need to know why.
Plus, the output quality can be a bit hit or miss.
Right.
And it doesn't always adapt well when you need that really specific, nuanced understanding of a domain.
Okay, but someone listening might say, hang on, what about RAG? Retrieval-Augmented Generation. That lets the LLM look things up in external documents. Doesn't that fix it?
Well, RAGs is definitely a step up. It helps ground the output in actual data, which is good. But the source highlights some research that really shows why just accessing data isn't always enough. The structure of that data is key.
Ah, this is the SQL database example, isn't it?
That's the one. They tested GPT-4 answering questions about data in a SQL database.
And the result. Just letting GPT-4 query it directly, accuracy was only, what, 16%?
16%. That's pretty low if you're relying on it for anything important.
Seriously.
Yeah.
But here's the kicker. They took the same data, but represented it as a knowledge graph, where the concepts and relationships are explicitly mapped out, structured.
A structured representation.
And they asked the same questions. Accuracy jumped to 54%.
Wow. Okay, that's a huge difference. It's not just about having the data. It's about having it organized in a way the AI can properly reason over.
Exactly. It really drives home the point that structure is critical for reliability, which leads us nicely into OMG, Ontology Model-centered Generation.
And the core of OMG is, well, the ontology model.
Right. Now, ontology sounds a bit philosophical, doesn't it? Like study of being.
It does have roots there, yeah.
Yeah.
But in computer science, it's more practical. The source mentions Gruber's definition, a formal specification of a shared conceptualization.
So like a formal map, a blueprint of the concepts and how they relate in a specific area.
Pretty much. It gives things formal names, defines relationships, organizes the knowledge in a structured way.
But the CAFA framework uses ontology model very specifically, right? It's not just a map, it's a computational model.
Exactly. That's the key distinction. It's a schematic representation, but one that's explicitly designed to be machine manipulable or machine friendly, built for computers to actually work with, to compute over.
So designed for machines?
But also human friendly.
Yeah.
It needs to be understandable, verifiable by actual human experts in the domain. They talk about ontological commitment.
Meaning?
Basically, the experts have to agree, yes, this model accurately reflects our understanding of this domain. It validates the structure and meaning.
Ah, so it's like a bridge. It captures human expertise in a way machines can use, but humans can still check and understand it.
Precisely. It's that bridge. So in OMG, this ontology model isn't just sitting there. It's the active, structured core that guides how the AI generates things and reasons about them. The source even calls it a kind of sophisticated feature engineering.
Okay, so you built this structured knowledge model. What does it actually do in the CAFA framework? The note mentions two main purposes.
Yeah, broadly speaking, first there's the ontology model for content and structure. This is for organizing the static knowledge.
Yeah.
The facts, the concepts, the what is known.
Like if you were building an AI tutor, the ontology model could map out the curriculum. Objectives, topics, prerequisites, how they link.
Exactly. Or for assessments, a measurement model ontology could define the skills or constructs being measured, the indicators for them, and their theoretical relationships. It structures the what.
And the second type?
That's the ontology model for change or prediction. This one's about capturing dynamics, how things change, evolve, or behave over time. How things change.
So more about processes, like maybe a growth model showing stages of learning.
Yep. Or a prediction model, defining variables and how they relate to forecast something, like student success or maybe system performance.
Gotcha. And these models, they can be built using different kinds of structures, depending on what you're modeling. It's not just one format.
Right. There's a toolkit. You've got your basic is a hierarchy, the taxonomy, like electric car is a car is a vehicle, simple tree structure.
Sense?
Then there's part of the mereological model. An electric car has part battery pack, describing things by their components, get more complex than a tree.
Okay.
DEGS-directed acyclic graphs are important too, for things like sequences, dependencies, processes that move forward without loops. Think workflows or maybe technology evolution paths.
And the note really highlights tabular representation too, just basic rows and columns like a spreadsheet or database table.
Yeah, which might seem simple, but it's crucial for making these models usable by machines. Computers are just really, really good at processing structured tabular data.
So it standardizes things, makes querying easy with SQL or Sparkle, helps with machine learning integration, scaling. It makes the ontology operational, basically.
Exactly. Translates the conceptual map into something the AI can crunch.
And lastly, it mentioned hierarchical structures.
Yeah, those are more like networks where things aren't strictly ranked. Elements can have multiple connections, sort of horizontal relationships, useful for modeling really complex stuff, maybe even aspects of cognition where knowledge isn't just top-down.
Okay, quite a range of tools there. So we've got the problems with log and arag. We understand what an ontology model is, its purposes, its structures. Let's tie it together. How does OMG, with this ontology model at the center, actually fix the problems?
Well, the core idea is putting this explicit structured knowledge, the ontology model, right in the middle, strategically guiding the AI components.
It's like giving the AI a verified structured brain for a specific domain.
Kinda, yeah. It acts as the framework ensuring everything is logically consistent and coherent. It helps integrate symbolic AI, like rule-based systems that are good at logic, with the generative power of LLMs.
So it's not about ditching LLMs, it's a hybrid approach.
Absolutely. OMG is described as a fusion. You get the precision, explainability, and logic from rule-based generation, RBG, guided by the ontology. And you combine that with the fluency and flexibility of language model-based generation, LOG LLMs. The LLM's creativity gets channeled and constrained by the structured knowledge.
Making it more robust for those specialized tasks we talked about.
Exactly. And the source explains how this helps resolve different kinds of conflicts. First, there's intercontext conflict resolution.
Meaning conflicts between different information sources.
Yeah, imagine the AI gets slightly different facts from two documents, or maybe conflicting opinions from experts, or even different AI modules disagree. The ontology model acts as that central reference point, the source of truth.
Ah, so it helps the AI filter, prioritize, figure out what's consistent with the established knowledge structure.
Right, it helps ensure the output is fact-based, logically sound, and reduces the risk of just repeating misinformation because it's anchored.
That seems huge. What about human conflicts?
Well, the process of building the ontology model itself forces human experts to get explicit about their knowledge and reach that ontological commitment, that agreement.
So the framework itself becomes a tool for humans to hash out disagreements and align their understanding.
Exactly. It provides a shared structure for discussion and refinement.
Okay, and machine-level conflicts.
That's about internal consistency within the AI, making sure its responses are grounded in the current context and that its internal memory or knowledge state remains consistent, always checking back against the ontology model.
Right, keeping itself honest, so to speak. So making the shift to OMG, it involves two main stages.
Seems so. First, you've got to do the hard work of taking existing human knowledge, which might be messy, unstructured, and actually build those computational ontology models. That's knowledge engineering.
Extracting, formalizing, structuring. Sounds intensive.
It definitely is.
Yeah.
But once you have those models, the second step is developing the collective AI in CAFA, that hybrid system.
The mix of LLMs and symbolic systems.
Right. And that AI then uses these structured models to do its work, generate content, update its knowledge, reason more reliably.
The source had a comparison table, didn't it? A log versus RAG versus OMG.
Yeah, it's pretty helpful. It lays out how the knowledge base differs implicit in log, external access in RAG, explicit and structured in OMG.
In flexibility, log and RAG are highly flexible. OMG is maybe medium constrained by the ontology, although the LLM part adds flexibility in how things are expressed.
But the payoff, where OMG is rated high, is accuracy and domain specificity. Because it's working within that defined, structured knowledge base, it's expected to be much more reliable and relevant within that domain.
So it's a trade-off. More upfront effort building and maintaining the ontology.
Definitely impacts initial efficiency and maybe scalability compared to just throwing data at an LLM.
But the potential return is much higher accuracy and deeper domain alignment, which you might not get otherwise.
Exactly. That's the value proposition.
So summing up the benefits of this OMG approach, what are the big wins?
Well, remember the black box problem. A huge advantage is easier validation and debugging.
Because the knowledge is explicit. You can actually look at the ontology model and see why the AI did something, or where the knowledge might be flawed.
Right. It's not just tweaking mysterious weights. And it leads to genuinely improved construct representation, clearer concepts, relationships, agreed upon by humans, used by machines.
And better collaboration seems key too. Humans and AI working from the same explicit playbook.
And even different AI agents could potentially collaborate more effectively if they share a common ontological grounding.
And maybe, down the line, even development efficiency could increase. If you can reuse parts of these ontology models for different applications in the same domain.
That's the hope, yeah. Reusability. Plus, things like enhanced security and construct preservation. The assessment example is good. Keep the core knowledge model secure and validated. Let the AI generate variations based on it.
So really, the note positions OMG as a vital step towards AI that isn't just a text generator, but something more. Cognitive, interpretable, aligned with how humans actually understand things.
Yeah, that seems to be the core message. It's about embedding structured, explicit knowledge to overcome the limits of purely pattern-matching systems.
And it's framed as this big picture, an overarching paradigm within CAFA, right? The source mentions specific frameworks built on OMG principles.
That's right. Things like Omega, Fish, Korea were mentioned as specific applications or sub-frameworks. They show how these OMG ideas get put into practice for particular tasks.
Could be interesting to look into those specifically sometime.
Definitely. See the theory in action.
Okay, so we've explored how structuring knowledge via ontology models is argued to be key for more reliable AI, better human-machine collaboration, and handling complexity.
It's about putting that explicit structure front and center.
Which leaves us with a final thought for you, the listener. If formalizing knowledge like this is so powerful for AI, what about us? How might consciously trying to structure and formalize our own knowledge or the knowledge within our teams using similar principles help us humans collaborate better, resolve disagreements, and maybe build deeper shared understanding in the complex fields we work in? Something to think about.